This video is for the arithmetic sequences introduction. So we're going to start with some vocabulary. So a sequence is a list of numbers or a collection of objects written in a specific order that follow a particular pattern. So the terms of a sequence are the numbers in a sequence. So all of these, this is a sequence, so each of these is considered a term. And then an arithmetic sequence is a sequence formed by adding or subtracting the same value to calculate each subsequent term. And then our other key word here is common difference. Now, a common difference is the difference between the terms in an arithmetic sequence. All right, so some notation that you need to know. We use A1, so that's a little one kind of written in the subscript. Superscript is where we write exponents. Subscript is when we write them down low. Represents the first term of the sequence. A of n represents the nth term of the sequence. A of n minus 1, doesn't show it very well, a minus sign there, represents the term before the nth term. So what this means is A of n, I can say, what's the ninth term? But I use this to represent any given term in the sequence, and then I use this to represent the term before any given term in a sequence. And then D represents the common difference of an arithmetic sequence. And these labels will make more sense once you use them. So the first thing we do is determine if the sequences below are arithmetic. So we look at the first two terms. We know it's arithmetic, so we know we're adding or subtracting something. So how did we turn a 4 into a 0? Well, 4 minus 4, let me get to this here. So 4 minus 4 gives me 0. If I subtract 4 again, I get negative 4. Subtract 4 again, I get negative 8. Subtract 4 again, I get negative 12. So this is, yes, this is an arithmetic sequence. And the D, the common difference, I subtracted 4 every time. So the common difference is a negative 4. Okay? So the other way you can go about it is you can look at the next term. But some of these are pretty easy. The arithmetic ones are easy to find the common difference. So to turn a 7 into a 10, we add 3. So to make this arithmetic, I have to be able to add 3 again to get the next term, and I can't do that. 10 plus 3 is 13. Now, if I add another 3, I do get 16, but 13 would have to be a term in the sequence. So no, this one is not arithmetic, because you have to do 10 plus 6 and then plus 3 again. And so it's not a constant pattern. So now we're going to find the next 3 terms. So again, we need to find the common difference. So if we add 3 to 3, we get 6. Plus 3 is 9. Plus 3 is 12. Plus 3 is 15. So 3 is my common difference. So I just keep going. I add another 3. So my next term would be 18. Add another 3, and I get 21. Add another 3, and I get 24. All right, this next one, negative 5.5 to negative 5.9. So I can always subtract negative 5.9 minus negative 5.5, and I get negative 0.4. So what they've done here, negative 5.5, they've subtracted 0.4 to get the term. So that's my common difference. And I keep going, and you can see that the pattern stays constant. So to keep the pattern going, I keep subtracting 0.4, and I get negative 7.5. So with these, always test out to make sure you're using the right common difference. Make sure you've got the right common term that you're using. All right, 15, 11, 7, 3, then a negative 1. So if I do 15 minus 4, I get 11, then I get 7, then I get 3, then I get a negative 1, so I keep going. So now I've got a 5, yep, minus 4, and then a negative 9, and then minus 4 again, and I get a negative 13. Okay, fractions. I know we don't like fractions. So again, what I can do is I can take the next term, I can take this negative 1/4, alpha y1, negative 1/4, and then let's subtract the preceding term, the 3/4. So I get a negative 1. So what this means, so let's test it out. Let's see if minus 1 does what I need. So 3/4 minus 1, negative 1/4, minus 1 again, negative 5/4, negative 9/4, and I can keep going. So I've got negative 17 over 4, negative 21 over 4, and then negative 25 over 4. And the other thing you'll find here, they've added 9 to the numerator every time, once we've kind of gotten to this area. So 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 4 is 17. So there's different methods that you can use here. Okay, so now let's look at geometric sequences. All right, so vocabulary here for geometric sequences. A geometric sequence is a sequence formed by multiplying or dividing the same value to calculate each subsequent term. This time we have a common ratio. So we have common difference with arithmetic sequences. We have a common ratio, and that's the ratio of successive terms of a geometric sequence. This is the number that we either multiply or divide each term by. So for a geometric sequence, our notation stays the same. A1 still represents the first term of the sequence. A to the n still represents the nth term of the sequence. A n minus 1 represents the term before the nth term of the sequence. And then r is the only change. R is the common ratio. Okay, so we know in these, we're going to determine if they're geometric. So we know we're multiplying or dividing. So what we can do with these is, again, like we did add or subtract, we can take 10.5 and let's divide it by 3.5. We get a 3. So we can test that as our common ratio. And multiply by 3 again, multiply by 3 again, multiply by 3 again. So yes, this is a geometric sequence where r, the common ratio, is 3. We multiplied by 3. So here we're starting with 0. Well, you should know that anything that we multiply by 0 is going to give us 0. So 0 is not going to be a first term of a sequence, just because you can't multiply anything by it to get anything other than 0. So no. If we went the other way, we did, started at the next term, 2.5, 5 times 2.5, we still don't have a common ratio. All right, find the next 3 terms. So what I'm going to do, as my numbers are getting bigger, so I'm going to divide. I'm going to divide the second term by the first term, and I get 3. So times 3, I should get 82.8, times 3, and just keep going. So 745.2, and you can see that these get bigger a lot quicker. Okay. All right, 32, 160, so I'm going to do 160 divided by 32. I get a 5. So 32 times 5 gives me 160, times 5 is 800, times 5 is 4,000. So again, we get big really quick here. Ooh, did you do that right? 32 times 5 is 800, times 5 is 4,000, times 5 is 20,000, times 5 is for some reason my brain's telling me that's not right. 32 times 5 is 160. Oop. Okay, sorry. Working through math. Okay, well let's just go with it. So 4,000 times 5 is 100,000 times 5 is 500,000. I think what I did, I think it was supposed to be 3, so I messed up somewhere in my typing, but it still works. Sorry, just working through some options here. Yeah, I must have goofed somewhere. Okay. Now we can see that the signs change. We go from a negative to a positive, but I can still do the same thing. 64 divided by negative 16. So I get a negative 4. So negative 16 times a negative 4 gives me a 64, times a negative 4 gives me negative 256, times a negative 4 gives me 124, times a negative 4 gives me negative 4,096, times a negative 4 gives me 16,384, times a negative 4 gives me negative 65,536. So you can see that in a geometric sequence, we can switch back and forth between negative and positives. All right, and the dreaded fractions. So I'm going to do 1/6 divided by 2/3, and I get 1/4. So I can multiply by a 4th, but my other option, multiplying by a 4th, let's see here, should be the same as dividing by 4. And so that just makes typing it in a little bit easier. So divide by 4 again. I get 1 over 1536 divided by 4. 1 over 6144. And I get a crazy number. So this one, again, I can look at the bottoms here. 24 to 96, 96 to 384. So let's see. Are we just multiplying the bottoms by 4? 24 times 4 is 96. 384 times 4 is 1536. Times 4 is 6144. So that's your other option if your calculator, your numbers start getting way too big or way too small. There's typically something deeper into the pattern.